Tonight, we're going to explore one of the most quietly tragic things the James Webb Space Telescope has ever witnessed. A death happening in slow motion across 13 billion years of space. We are going to watch a galaxy kill itself. That is not a metaphor, and it is not an exaggeration. There is a galaxy in the early universe, a vast island of hundreds of millions of stars that is right now, in the ancient light reaching us, actively destroying its own future. It is not being attacked. Nothing is hunting it. There is no collision tearing it apart from outside, no black hole devouring it, no nearby disaster. The galaxy is doing this to itself. It is taking the very material it needs to go on living, the cold gas from which all its future stars would be born, and it is blowing that material out into empty space, hurling it away faster than it can ever use it, at well over 1 million miles an hour. The galaxy is, in the most literal sense, throwing away its own future. The galaxy has a name, Crystal Zeus, and James Webb, working together with a great array of radio telescopes in the deserts of Chile, has caught it in the act. We're watching a galaxy commit a slow and silent suicide, and tonight, we're going to find out why. By the end of tonight, you're going to understand one of the deepest mysteries in the study of galaxies, the question of why so many of the largest, brightest galaxies in the early universe suddenly stopped forming stars and went dark, becoming what astronomers call red and dead, long before the universe had even grown up. You're going to understand how a galaxy can possibly turn on itself, what force could drive it to expel its own lifeblood, and why this strange act of self-destruction may be one of the most important and most common processes in all of cosmic history. And you are going to understand why Crystal 02 is not a freak, not a single doomed oddity, but a window onto something that may have happened, and may still be happening, to galaxies all across the universe, including, in the deep future, perhaps, our own. This is a journey into the life and death of galaxies, into the strange truth that the act of creation and the act of destruction can be the very same act, and into a quiet cosmic tragedy unfolding in the deep infrared. There is no need to follow every number. There is no test at the end. The only thing tonight asks is that you let your body grow still while your mind drifts out to a dying galaxy at the dawn of time. Before we begin, if you find that these slow journeys through the real universe help to quiet your mind at the end of the day, take a moment to subscribe so the next one can find you when you need it. If you're listening on Spotify, the follow button does the same gentle work, and it helps these long drifts through the dark reach more people than you would think. That is all. Settle in, lower the lights, let your breathing slow. Now, let's begin not with the dying galaxy itself, but with the mystery that made its discovery so important. A puzzle that has troubled astronomers for years, the strange case of the galaxies that died too soon. Let me set the scene, because to understand why a single dying galaxy matters so much, you have to understand what astronomers expected the early universe to look like, and how badly the real universe has refused to cooperate. The story of a galaxy, as we long understood it, is a story of slow and steady growth. A galaxy gathers cold gas, mostly hydrogen, the simplest and most abundant material in the universe. That cold gas, pulled together by gravity, collapses and condenses, and from it new stars are born, lighting up one after another. The galaxy shines, its stars live out their lives, and over billions of years more gas flows in, more stars form, and the galaxy grows richer and brighter and more massive, generation after generation of stars, a slow and patient accumulation of light. That is how it is supposed to work. Star formation is the heartbeat of a galaxy, and as long as there is cold gas to feed it, that heartbeat goes on. Before we get started, to really feel what Crystal 02 is losing when it expels its cold gas, we should understand what that cold gas actually is and how stars are born from it. Because the cold gas is not just fuel in the abstract. It is the literal stuff that becomes stars and planets, and in the long run, everything. A galaxy's cold gas is mostly molecular hydrogen atoms paired into molecules, sitting in vast dark clouds scattered through the galaxy. These clouds are astonishingly cold, hundreds of degrees below zero, and astonishingly empty by earthly standards, far thinner than any vacuum we can make in a laboratory. But they are enormous, light years across, and they contain tremendous amounts of material, the mass of thousands or millions of suns in a single cloud. And they are cold enough, and in places dense enough, that gravity can take hold of them. Where a clump of the cloud grows dense enough, gravity begins to pull it inward, and it starts to collapse. As a clump collapses, it heats up, squeezed tighter and tighter by its own gravity, the temperature at its centre climbing higher and higher. And if the clump is massive enough, the centre eventually grows so hot and so dense that something extraordinary happens. The hydrogen at the core begins to fuse, hydrogen nuclei slamming together to form helium, releasing energy in the process. A star ignites. The outward push of that fusion energy balances the inward pull of gravity, the collapse halts, and a new star settles into a long stable life, shining steadily, turning hydrogen into helium and light for millions or billions of years. That is the birth of a star, and it happens only because there was cold gas, cold enough and dense enough for gravity to gather it and light it. This is why cold gas is everything to a galaxy. It is not a metaphor to call it lifeblood. Cold gas is the one and only material from which new stars can form. Without it, the galaxy is sterile. The existing stars will live out their lives and slowly die, the bright young blue ones first, leaving only the long-lived dim red ones, and no new stars will arrive to replace them. The galaxy will fade and redden, not because anything happens to its old stars, but simply because no new ones are being born. A galaxy without cold gas is a galaxy that has lost the ability to make a future. It still has its present, its existing stars, but its future has been taken away. So when crystal Zo2 expels its cold gas into the void, understand exactly what it is throwing away. Not just abstract fuel, but every star it might ever have made, every stellar nursery that would have lit up, every planet that might one day have formed around those stars, every possibility the galaxy contained for renewal, for going on, for remaining alive and bright. All of it was bound up in that cold gas, and all of it is streaming out into intergalactic space at over 1,000,000 miles an hour, never to return. The galaxy is not just losing material, it is losing every future it could have had, hurling its own unborn stars into the dark. No one expects the cold dark clouds of a galaxy, hundreds of degrees below zero and thinner than any vacuum, to be the single most precious thing it owns, but they are, because they are the only place new stars can be born. No one predicts that to expel that cold gas is to throw away not just fuel, but every possible future, every star and planet that might ever have formed. And absolutely no one anticipates how total the loss is, how a galaxy that loses its cold gas has not merely been wounded, but has had its entire capacity for renewal carried away into the void, its future scattered to the intergalactic dark. So when astronomers look back at the early universe, at the first few billion years after the Big Bang, they expected to find galaxies in the full flush of youth, busily forming stars, growing steadily, their heartbeats strong, and many of them are exactly that. But scattered among them, astronomers kept finding something that did not fit at all, something that should not have been possible so early. They found galaxies that were already finished, massive galaxies, full of stars that had simply stopped. No new stars forming, no cold gas left to form them, their heartbeats silenced, their growth halted, their light slowly reddening as their existing stars aged, and no new blue stars arrived to replace them. Astronomers call these galaxies quiescent, or more vividly, red and dead, and finding them in the early universe was a genuine shock. They had died young, impossibly young, and no one was sure how. Now, let's begin to understand why Crystal 02's violent fate may have been so common. We need to picture the early universe it lived in, because that universe was a profoundly different and more violent place than the calm cosmos around us today, and its very nature drove galaxies toward exactly this kind of death. Go back to the first 1 or 2 billion years after the Big Bang, the era Crystal 02 lived in. The universe was much younger and much smaller, the great cosmic expansion having had far less time to carry things apart. Galaxies were packed close together, crowded into the dense early structures, jostling and colliding far more frequently than they do now. And they were rich with cold gas, the universe still holding vast reservoirs of the pristine fuel from which stars are made, not yet expelled or used up. Crowded galaxies, abundant gas, frequent collisions. This was the recipe for furious star formation. The early universe was a place of starbursts, galaxies igniting again and again in brilliant bursts of creation as they collided and crushed their plentiful gas together. This is why the early universe was, in a sense, primed for the kind of death we have watched in Crystal 02. The very conditions that made it a time of vigorous creation, the crowding, the collisions, the abundant gas, were the same conditions that drove galaxies into the furious starburst that killed them. A galaxy in the crowded early universe was far more likely to suffer a major collision, far more likely to ignite a violent starburst, and therefore far more likely to drive a galaxy-killing wind and quench itself than a galaxy in the calm, spread-out universe of today. The early cosmos was not just a time of more creation, it was a time of more violent creation, and violent creation, as Crystal 02 shows, is exactly the kind that kills. So the early universe was a place of brilliant, brief, violent lives. Galaxies formed fast, collided often, blazed in furious starbursts, and many of them, through the very intensity of those bursts, died young, expelling their fuel and falling silent. It was a turbulent, dramatic era, galaxies flaring and dying all across the young sky, the great giants among them living fastest and dying first. The calm, stately spiral galaxies of today, our own Milky Way among them, gently forming their stars over billions of years, are in many ways the survivors and the latecomers, galaxies that avoided the most violent early deaths, or formed in calmer circumstances, and so lived on into the quieter modern universe. The early cosmos belonged to the brilliant and the doomed, the galaxies that burned brightest and briefest. Crystal 02, then, is not just a single dying galaxy. It is a representative of an entire era, a window onto what the early universe was truly like, a time of crowded, violent, furious creation in which death came swiftly to the brightest. When we watch Crystal 02 expel its fuel and prepare to fall silent, we are watching not an isolated tragedy, but a characteristic moment of the cosmic dawn, the kind of brilliant, violent death that was playing out across the young universe, again and again, as galaxy after galaxy blazed too brightly and burned itself out. No one expects the time of greatest cosmic creation to also be the time of swiftest cosmic death, but in the crowded, violent early universe, the two went hand in hand. No one predicts that the very conditions that made the cosmic dawn so brilliantly creative, the crowding and collisions and abundant gas, would be the same conditions that drove galaxies to kill themselves. And absolutely no one anticipates how Crystal 02 stands for a whole era, a single clear window onto a young universe full of brilliant doomed galaxies, blazing and dying all across the early sky. That is the mystery Crystal 02 helps to solve. Because to find a galaxy that is already dead tells you only that it died. It does not tell you how. To learn how, you would need to catch a galaxy in the very act of dying, at the moment of self-destruction, with the murder weapon still in view. And that is exactly what James Webb and the radio telescopes of Chile have done. Tonight, we're going to sit with that mystery a little longer, the puzzle of the galaxies that died too soon, because it is stranger and more important than it first appears. In the universe today near us, there are two broad kinds of large galaxies, and they look completely different. There are the spirals like our own Milky Way, great flat rotating disks with graceful arms, blue and bright with young stars still actively forming new ones, still alive. And there are the ellipticals, smooth featureless balls of stars, no spiral arms, no disk, glowing a dull reddish gold. The ellipticals are the dead ones. They finished forming stars long ago, and what we see now is the slow, fading glow of their old surviving stars, the red and dead remnants of galaxies whose star formation switched off and never came back on. A spiral is a galaxy still living its life. An elliptical is a galaxy in its long afterlife. We have spoken of Crystal 02's death, but death is the wrong word for what comes after, and it is worth dwelling on the long afterlife that awaits the galaxy, because it is far longer and far gentler than the brief violent dying we have been watching. When Crystal 02 finishes expelling its gas and its star formation ends, the galaxy does not vanish. It becomes a red and dead elliptical, and it will remain one for an immense span of time, far longer than its brief star-forming life. Its existing stars, the ones already formed, will go on shining. The brightest and most massive of them, the brilliant blue ones, will die first over the next few 100 million years in supernovae and slow collapses. And once they are gone, with no new blue stars forming to replace them, the galaxy will take on the colour of its remaining population, the smaller, dimmer, longer-lived stars, which glow in warmer reddish and golden tones. The galaxy will redden, settling into the dull gold colour of an old elliptical, and there it will stay. And it will stay there for an almost unimaginable length of time. These small red stars that will dominate Crystal 02's afterlife are extraordinarily long-lived. A star much smaller than our Sun can shine steadily for tens of billions of years, even hundreds of billions, far longer than the current age of the universe. So Crystal 02, having died as a star former in a brief furious instant, will live on as a quiet red elliptical for a span of time that dwarfs its entire star-forming life many times over. Its dying took tens of millions of years. Its afterlife will last tens of billions, perhaps hundreds of billions. The galaxy will spend the overwhelming majority of its existence not as the brilliant blue star former we are watching, but as the quiet golden elliptical it is about to become. The death we have witnessed is not an ending. It is a transition into the galaxy's longest and most peaceful phase. There is something that reframes the whole story in this. We have been calling Crystal 02 a dying galaxy, and in the narrow sense of its star formation, it is. But step back and look at the full arc of its existence, and the dying is only a brief violent doorway between two long phases. There was the gathering, and the collision, and the brilliant burst, the bright loud chapter we are watching. And there will be the long quiet golden afterlife, tens of billions of years of gentle red light, the galaxy's existing stars slowly aging in peace. The death is the thin dramatic line between them, the moment of transition, over almost as soon as it begins. By far the largest part of Crystal 2's life is not its dying but its long serene afterward, which is only now about to begin. So when we watch Crystal 2 expel its fuel and prepare to fall silent, we are not really watching an ending at all. We are watching a galaxy step through the doorway from its brief loud youth into its vast quiet maturity, from the burning blue star former into the calm golden elder it will be for almost all of the rest of cosmic time. The red and dead galaxies that fill the modern universe, the ones whose early deaths so puzzled astronomers, are not corpses in any real sense. They are galaxies in their long, peaceful afterlives, their existing stars glowing on, gently, golden, for spans of time we can barely conceive. Crystal 02 is about to join them and to remain among them, quietly, long after every star now burning in our own sky has died. No one expects a dead galaxy to have an afterlife far longer than its life, but that is the truth of the red and dead ellipticals, tens of billions of years of quiet golden glow following a brief star-forming youth. No one predicts that Crystal 02's dying, so dramatic in our telescopes, is only a thin doorway between its short, loud life and its vast, serene maturity. And absolutely no one anticipates how the word death dissolves once you see the whole arc into something far gentler, a transition into the longest and most peaceful phase of a galaxy's existence, the calm golden afterward that lasts almost forever. For a long time, the natural assumption was that galaxies die slowly and late, that it takes most of the age of the universe for a galaxy to use up its gas and gradually fade into the red and dead state. And for many galaxies, that may be roughly true. But when Webb and other powerful telescopes looked deep into the early universe, they found massive red and dead galaxies that were already finished when the universe was only a small fraction of its current age, sometimes only 1 billion or 2 billion years after the Big Bang. These were not small galaxies that had quietly run out of fuel. They were giants, some of them more massive than the Milky Way, that had formed an enormous number of stars extremely quickly, and then, just as quickly, shut down completely. They had lived fast and died young, and they had done it on a time scale that the slow and gentle picture of galaxy death simply could not explain. This is the puzzle astronomers call quenching, the sudden and mysterious switching off of star formation in a galaxy. And quenching is one of the central unsolved problems in the study of galaxies because something has to do it. A galaxy does not stop forming stars on its own as long as it has cold gas. The cold gas is the fuel, and as long as the fuel is there, gravity keeps lighting new stars from it. So to quench a galaxy, to kill it, you have to do one of two things. You have to either heat the cold gas up so it can no longer collapse into stars, or you have to physically remove the cold gas from the galaxy altogether, take away the fuel. Either way, something has to intervene, some powerful process has to reach in and stop the heartbeat. And the deeper question, the one that has driven years of research, is what that process is and how it can act so fast and so completely on galaxies so large, so early in the history of the universe. Before we begin, let us clear away a few misunderstandings about what is happening to Crystal 02, because the idea of a galaxy killing itself is exactly the kind of thing that grows distorted in the telling, and the truth is both stranger and gentler than the distortions. The first misunderstanding is that the galaxy is exploding, or being torn apart or destroyed in some violent visible catastrophe. It is not. From the outside, over any human timescale, Crystal 02 would look perfectly serene, a bright galaxy busily forming stars, nothing obviously wrong. The death is not an explosion. It is a slow expulsion of gas, playing out over tens of millions of years, far too gradually for any sudden drama. The galaxy is not blowing up. It is very slowly blowing away its fuel, and the consequence, the end of its star formation, will arrive quietly, not with a bang, but with a gradual fading. The word kill is vivid, and it is accurate in its way, but the act itself is patient and almost imperceptible, a slow exhalation, not a detonation. The second misunderstanding is that the galaxy's existing stars will die when the galaxy is quenched. They will not. Quenching does not destroy the stars that already exist. It only stops new ones from forming. When Crystal 2 expels its cold gas and its star formation ends, all of its existing stars will go on shining, living out their natural lives exactly as they would have anyway. The galaxy will not go dark suddenly. It will simply stop making new blue stars, and as its existing blue stars age and die over hundreds of millions of years with no new ones to replace them, the galaxy will gradually redden into the dull gold of an old elliptical. The death is the death of the galaxy's fertility, its ability to make new stars, not the death of its existing population. The galaxy lives on for tens of billions of years as a red and dead elliptical. It just never makes anything new again. The third misunderstanding is that this is a rare and unnatural fate, some freak accident. It is the opposite. Quenching by galactic wind appears to be a common and natural part of how galaxies evolve, especially in the early universe. Galaxies are born, many of them form stars vigorously, and many of them, in time, quench by one mechanism or another and settle into their long red afterlives. The red and dead ellipticals that fill the modern universe are not victims of disaster. They are simply galaxies that have completed this natural transition from the star-forming phase of their lives to the quiescent phase. Crystal, too, is not suffering a freak misfortune. It is undergoing a transformation that a great many galaxies undergo, one of the normal chapters in the long life of a galaxy. The fourth misunderstanding is that because a galaxy can kill itself this way, our own Milky Way is in imminent danger. It is not. The Milky Way is forming stars at a gentle, steady rate, nothing like the furious self-destructive burst of Crystal 02. We do have galactic winds, mild ones, lifting some gas above and below our disk, but we also have gas flowing in to replenish what we form, and our star formation is sustainable, balanced, not a runaway burst. The Milky Way will go on forming stars for billions of years yet. Crystal 02 shows us the machinery turned all the way up to lethal intensity, but in our own galaxy that same machinery runs gently, sustainably, a quiet heartbeat rather than a fatal fever. No one expects the death of a galaxy to be so quiet, so gradual, so survivable for the stars within it, but that is the gentle truth behind the vivid word kill. No one predicts that quenching, far from being a freak catastrophe, would be one of the normal chapters in the ordinary life of a galaxy. And absolutely no one anticipates how reassuring the full picture is. Once you see that Crystal 02 is not exploding, its stars are not dying, its fate is not rare, and our own galaxy is in no danger, only a galaxy undergoing, in a particularly dramatic way, a transformation as natural as the turning of a season. No one expects the early universe, the time of cosmic youth and vigorous growth, to be littered with the corpses of giant galaxies that died before their time, but that is what the deep surveys keep finding. No one predicts that the largest galaxies, the ones with the most fuel, would be among the first to die, switching off their star formation while smaller galaxies kept going. And absolutely no one anticipates how stubborn the mystery would prove, how the question of what kills these galaxies and how it acts so quickly would remain one of the great open problems in all of galaxy science year after year, waiting for someone to catch the killer in the act. Here is the picture to hold as we go forward. Expectation. Galaxies are born, they grow steadily, and they die slowly and late, fading gently over most of the age of the universe as they gradually exhaust their fuel. Reality. Some of the largest galaxies in the cosmos formed in a furious burst, and then died abruptly and early, switched off hard while the universe was still young, by some violent process powerful enough to silence a giant in a cosmic instant. The corpses were everywhere. The crime was clear. But the murder weapon and the murderer had never been caught in the act. Now let's begin with a deeper puzzle hidden inside the story of the early dead galaxies, one of the most counterintuitive findings in all of galaxy science, and Crystal 02 speaks directly to it. Astronomers call it downsizing, and it turns the expected order of things completely upside down. Here is what you would naturally expect. In the standard picture of how cosmic structure grows, small things form first and large things form later. Small clumps of matter gather into larger ones over time, small galaxies merge into big ones, and so the biggest galaxies should be the last to finish assembling. From this, you would reasonably predict that the biggest galaxies should also be the last to finish forming their stars, the slowest to mature, the latest to die. The giants, having the most fuel and taking the longest to build, should keep forming stars long after the little galaxies have settled down. Big galaxies should be the late bloomers, still going strong while the small ones fade. The real universe does precisely the opposite, and this is downsizing. When astronomers look at the actual record, they find that the most massive galaxies formed their stars earliest and fastest, and died first. The giants finished their star formation early in cosmic history, becoming red and dead while the universe was still young. The smaller galaxies, by contrast, kept forming stars for much longer, many of them continuing right up to the present day. So the order is inverted. The big galaxies lived fast and died young. The small galaxies live slow and die late, or have not died yet at all. The largest galaxies, which you would expect to be the last to finish, were actually the first to go. Star formation has, over cosmic time, been shifting from the largest galaxies to progressively smaller ones, downsizing, the action moving down the scale from giants to dwarfs as the giants fall silent one by one. This is a genuine puzzle, and it is exactly the kind of puzzle that Crystal Zero 2 helps to solve, because if the largest galaxies die by violent self-quenching, by furious starbursts that drive galaxy-killing winds, then their early death makes sense. The giants, with their deep gravity, gathered and crushed their gas fastest, often through the frequent collisions of the crowded early universe, igniting the most furious starbursts. And those most furious starbursts drove the most powerful winds, expelling the gas fastest and quenching the galaxy soonest. The very thing that made them giants, their ability to gather and burn gas rapidly, is what killed them early. They burned hottest, and so they burned out first. Crystal Zero 2, a massive galaxy in a furious collision-driven starburst dying young, is downsizing caught in the act. A giant living fast and dying first, exactly as the puzzle describes. So the strange inverted order of galactic death, the giants dying first and the dwarfs lingering, may come down in large part to this. The biggest galaxies were the most capable of the violent self-destruction we are watching in Crystal Zero 2, and so they died of it first, while the smaller, gentler galaxies, never igniting such furious bursts, lived quietly on. Death, in the universe of galaxies, came for the greatest first, and Crystal Zero 2 shows us one of those greatest in its final act. No one expects the largest galaxies, with the most fuel and the longest assembly, to be the first to die, but that is the inverted order the universe actually follows. No one predicts that the giants would burn out fastest precisely because they burned hottest, their very greatness driving the furious starbursts that killed them, and absolutely no one anticipates how neatly Crystal Zero 2 resolves the puzzle, a massive galaxy caught in the violent self-quenching that explains why the greatest galaxies died young, downsizing made visible in a single dying giant at the dawn of time. Until, that is, James Webb and a great array of radio dishes in the Chilean desert turned together toward a galaxy called Crystal Zero 2 and found it not dead, but dying, with the weapon still in its hand. To catch a galaxy in the act of dying, you have to be able to see two things at once, and they are very different things, visible to very different kinds of telescope. This is why the discovery of Crystal Zero 2's self-destruction took not one instrument but two, working together, each seeing what the other could not. The first thing you need to see is the stars and the hot glowing gas, the bright visible life of the galaxy, the places where new stars are being born and lighting up the gas around them. This is the work of the James Webb Space Telescope, with its infrared eyes peering back across 13 billion years to catch the faint, stretched light of the early galaxy. Webb can see where Crystal Zero 2 is forming its stars, can map the hot ionized gas glowing around those bright young stellar nurseries, can show us the living, burning body of the galaxy. But the thing that is actually killing the galaxy is not the hot, bright gas. It is the cold gas, the dark, frigid, invisible molecular hydrogen from which new stars are made, the galaxy's true fuel and lifeblood. And cold gas does not glow in visible or infrared light, It is dark and cold and silent, and Webb, for all its power, largely cannot see it. To map the cold gas, you need a completely different kind of telescope, one that listens not for light, but for the faint radio whisper that cold gas gives off. And the greatest such instrument in the world sits high in the Atacama Desert of Chile, a vast array of 66 radio dishes spread across a high dry plateau, working together as a single enormous telescope. It is called ALMA, the Atacama Large Millimeter Array, and it is built precisely to see the cold, dark, star-forming gas that everything else misses. Tonight, we're going to spend a few minutes on ALMA, the instrument that made this discovery possible, because it is one of the most extraordinary telescopes ever built, and most people have never heard of it. High in the Atacama Desert of northern Chile, on a plateau more than 16,000 feet above sea level, sits a field of giant radio dishes. There are 66 of them, each one a precisely shaped antenna, some of them as wide as a small house, spread across the bone-dry high desert. This is ALMA, the Atacama Large Millimeter Array, and it does not see light the way your eyes or an ordinary telescope do. It listens for radio waves, specifically for the faint signals given off by cold gas and dust in space, signals with wavelengths around a millimeter, far longer than visible light, invisible to every ordinary telescope. The location is no accident. Cold, dry air is essential, because water vapor in the atmosphere absorbs exactly the kind of signals ALMA is trying to detect. The Atacama is one of the driest places on Earth. Some parts of it have not seen rain in recorded history, and the high plateau lifts the array above much of the atmosphere's interfering moisture. The conditions are brutal for the people who work there. The air so thin that visitors need supplemental oxygen, but for the telescope, they are perfect. It is one of the few places on the planet where the cold whisper of distant gas can be heard clearly. And the 66 dishes work together as one. This is the deep cleverness of ALMA. By combining the signals from all the dishes spread across the desert, sometimes miles apart, the array behaves like a single telescope as wide as the distance between its most separated dishes. The dishes can even be moved, carried on enormous custom-built transporters to different positions across the plateau, spreading them out for sharper vision or drawing them together for greater sensitivity. It is a telescope that can reshape itself, a single instrument made of dozens of pieces scattered across a desert, listening together to the faintest radio murmur of the cosmos. What ALMA is built to hear, above all, is the cold molecular gas and dust where stars are born, the very material that everything else struggles to see. The hot bright gas around young stars glows in visible and infrared light, and telescopes like Webb catch it beautifully. But the cold, dark reservoirs of gas, the actual fuel, the frigid molecular hydrogen waiting to collapse into stars, give off almost no light at all. They reveal themselves only in the faint radio glow of certain molecules mixed in with the hydrogen, and it is precisely that glow that ALMA is designed to detect. This is why Crystal 02's story needed ALMA. Webb could see the galaxies burning life. Only ALMA could see the cold fuel streaming away into the dark. The murder weapon was visible only to the great array in the desert. No one expects the way to watch a galaxy die 13 billion light-years away would run through a field of radio dishes in the driest desert on Earth, but that is exactly the path. No one predicts that the coldest, darkest, most invisible material in a galaxy, the very stuff that decides its life and death, would be readable only in a faint radio whisper caught high in the Atacama. And absolutely no one anticipates how much of the universe stays hidden until you build precisely the right strange instrument to hear it. 66 dishes on a frozen plateau, listening together to the breath of dying galaxies. So astronomers pointed both of them, Webb and ALMA, at Crystal 02, a galaxy we see as it was only about 1 billion years after the Big Bang in the deep cosmic dawn. Crystal 02 is part of a survey, the ALMA Crystal Survey, designed to map the cold gas and the star formation in early galaxies together, and Crystal 02 was caught in a dramatic moment. In the final stages of a collision, two clumps of galaxy merging into one, the kind of violent encounter that triggers a tremendous wave of new star formation. Webb showed the team where the stars were forming, ALMA showed them where the cold gas was, and when they put the two pictures together, they saw something that stopped them. Tonight we're going to understand why Crystal 02 was caught in the middle of a collision, because the collision is what lit the fuse, and galaxy collisions are far more common and far stranger than most people imagine. In the early universe, galaxies were packed much closer together than they are today. The cosmos was younger and smaller. The great expansion had not yet carried things so far apart, and galaxies crowded into the dense early structures, jostling, passing close to one another, frequently colliding and merging. Collisions were not rare disasters in the early universe. They were a normal part of how galaxies grew. Small galaxies merged into larger ones, and larger ones merged into larger ones still. The great galaxies of today assembled in part from the wreckage of countless early mergers. Crystal 02 itself, the astronomers found, was in the final stages of exactly such a merger. Two clumps coming together into one, and when galaxies collide, something counterintuitive happens to their gas. You might expect a collision to simply scatter everything, to fling the gas apart. And on the larger scale, mergers do throw out long streamers of stars and gas into space. But in the crowded center, where the two galaxies' gas clouds slam into each other, the opposite happens. The gas is compressed, violently, squeezed together as the two reservoirs collide, and compressed gas is exactly what makes stars. Squeeze a cloud of cold gas hard enough, and it collapses, igniting stars in tremendous numbers. So a collision, rather than sterilizing the galaxies, triggers a great wave of star formation, a starburst, as the colliding gas is crushed into new stars all at once. The violence of the merger becomes the spark of creation. This is why so many starbursts, including Crystal 02's, are triggered by collisions. The merger crushes the gas ignites into a furious burst of star formation, and that is the beginning of the whole chain we have traced tonight. Because the starburst, as we have seen, makes the massive stars, and the massive stars drive the wind, and the wind expels the fuel, and the galaxy dies. The collision is the first domino. It is the event that takes a galaxy quietly forming stars and tips it into the violent burst that will, through its own stellar feedback, bring about its end. Crystal 02 was killed, in a sense, by a collision, but not directly. The collision did not destroy it. The collision lit the starburst, and the starburst killed it. The murder weapon was the galaxy's own stars, but the collision put the weapon in its hand. There is a strange beauty in this chain, the way one thing flows into the next. Two galaxies drift together over millions of years, drawn by gravity. They merge, and their gas is crushed, and from that crushing a brilliant burst of new stars is born. And those very stars, in their brief furious lives and violent deaths, drive the wind that scatters the remaining fuel and silences the galaxy. Collision becomes creation, becomes destruction, each step the natural consequence of the one before, a single unbroken sequence from the meeting of two galaxies to the death of the one they became. No one expects a collision to create stars rather than destroy them, but in the crowded center of a merger, the crushing of gas does exactly that, igniting a starburst. No one predicts that this burst of creation, born from collision, would carry within it the seeds of the galaxy's death, the massive stars that drive the killing wind. And absolutely no one anticipates how the whole tragedy flows from a single gentle beginning, two galaxies drawn together by gravity across the early universe, their meeting setting in motion everything that follows, all the way to the quiet death at the end. Now, let's begin with what they actually found, because it is the heart of tonight's story. Crystal 02 was forming stars at a furious rate, roughly twice as fast as other galaxies of similar size, a true starburst, blazing with new stars triggered by the collision. That alone was dramatic but not surprising. The shock came from the cold gas. ALMA revealed that the cold molecular gas of Crystal 02 was not staying put, not quietly feeding the galaxy. A great plume of it was streaming outward, away from the galaxy, extending some 7,000 light-years out into the empty space beyond, a vast tongue of frigid gas being expelled into the intergalactic dark. The galaxy was not holding on to its fuel. It was hemorrhaging it, pouring its own lifeblood out into the void. And when the astronomers measured how fast that gas was being driven out, the numbers were staggering. The cold gas was being expelled at a speed of hundreds of miles per second, well over 1,000,000 miles an hour, fast enough to escape the galaxy entirely and never return. And the rate of loss was the real shock. Crystal 2 was blowing its cold gas out into space at roughly twice the rate at which it was forming stars. Think carefully about what that means. For every measure of gas the galaxy turned into new stars, it was hurling twice as much of that same precious gas out into the void, lost forever. The galaxy was using its fuel and throwing away even more of it at the same time, spending and wasting its lifeblood far faster than it could ever replace it. It is worth understanding how astronomers can possibly measure the speed and motion of cold gas in a galaxy 13 billion light-years away, because the technique is subtle and clever, and it is the very thing that let them clock the killing wind. The cold gas that ALMA detects reveals itself through specific signals, particular wavelengths of radio light emitted by certain atoms and molecules mixed into the gas. One of the most important of these is a signal from carbon, a specific glow that cold gas gives off, bright enough to detect even across the vast gulf to the early universe. Astronomers call it the carbon line, and it is one of the workhorse signals for studying cold gas in distant galaxies, because it shines clearly and traces the gas faithfully. When ALMA looks at Crystal 02, this carbon glow is one of the main things it sees, mapping out where the cold gas lies. But the signal does more than reveal where the gas is. It reveals how the gas is moving, and this is the key to measuring the wind. The trick is an effect you've experienced yourself with sound. When an ambulance races toward you, its siren sounds higher in pitch, and as it passes and races away, the pitch drops. This is the Doppler effect, the shifting of waves by the motion of their source, and it works for light just as it works for sound. Gas moving toward us has its signal shifted slightly toward shorter wavelengths, toward the blue. Gas moving away from us has its signal shifted toward longer wavelengths, toward the red. By measuring exactly how the carbon glow is shifted, astronomers can read the speed of the gas, how fast it is moving toward us or away, with great precision. So when ALMA studied the carbon glow streaming out of Crystal 2, it could read not just that the gas was there, but how fast it was moving. And the signal showed gas moving outward at tremendous speed, hundreds of miles per second, the unmistakable fingerprint of a powerful wind driving the gas away from the galaxy. The breadth of the signal, the range of speeds it covered, told the story of a great outflow. Gas being expelled across a wide range of velocities, the fast, violent wind of a galaxy blowing out its fuel. The murder weapon was not just visible, it was measurable. Its speed read directly from the shifting of a glow of carbon across 13 billion light-years. There is something wonderful in the precision of it. From a faint radio whisper, caught by dishes in a desert, astronomers can not only find the cold invisible gas of a galaxy at the dawn of time, but clock its exact speed as it streams away, reading the velocity of a wind that blew 13 billion years ago from the subtle shift in the colour of its light. The whole drama of Crystal 2's death, the direction and speed and force of the killing wind, is written in the fine details of that carbon glow, waiting for an instrument sensitive enough to read it. ALMA was that instrument, and the story it read was the story of a galaxy expelling its life at over 1,000,000 miles an hour. No one expects the speed of a wind from 13 billion years ago to be readable from the faint glow of carbon, but the Doppler shift writes that speed into the light for anyone able to measure it. No one predicts that the same effect that raises the pitch of a passing siren would let astronomers clock the dying breath of a distant galaxy. And absolutely no one anticipates how much can be wrung from so faint a signal. The presence, the location, the speed, and the violence of a galaxy-killing wind, all read from a thread of carbon light stretched across the whole history of the universe. By the end of tonight, you're going to understand a subtle but crucial detail about Crystal 02's death that deserves its own moment, because it is what makes the discovery so significant, and it concerns the difference between two kinds of gas and which kind is being expelled. A galaxy's gas comes in different phases at very different temperatures. There is hot ionized gas, gas that has been heated to high temperatures, its atoms stripped of electrons, glowing fiercely. And there is cold molecular gas, the frigid dense gas, hundreds of degrees below zero, where atoms pair into molecules, the gas from which stars are actually made. These two phases behave very differently when a galactic wind blows through, and the difference is the whole point. Hot gas is relatively easy to drive out of a galaxy. It is already energetic, already moving fast, light and diffuse, and the energy of a starburst can sweep it up and blow it outward without too much difficulty. For a long time, when astronomers studied galactic winds, it was mostly this hot gas they could see being expelled, glowing as it streamed away. Expectation. Any wind that blows gas out of a galaxy must be killing it. Reality. Driving out the hot gas, while dramatic, is not necessarily lethal to a galaxy, because the hot gas is not the fuel. The hot gas cannot form stars. A galaxy can lose its hot gas and still go on making stars from its cold reservoir, as long as that cold reservoir remains. Expelling the hot gas alone does not kill a galaxy. It only clears away material that was not making stars anyway. The cold molecular gas is a completely different matter. It is dense and heavy, and gravitationally bound, hard to move, clinging to the galaxy. And it is the fuel, the only material from which new stars can form. To drive out the cold molecular gas is far harder than driving out the hot gas, requiring a much more powerful wind, and it is far more lethal because it strips away the galaxy's actual capacity to make stars. A galaxy that loses only its hot gas can survive. A galaxy that loses its cold molecular gas is finished because its fuel itself is gone. And this is exactly what makes Crystal 02's death so striking and so important. ALMA did not just see hot gas being expelled. It saw the cold molecular gas, the dense star-forming fuel being driven out, the hard-to-move, lethal-to-lose material streaming away into the void. The wind was powerful enough to expel not just the easy hot gas, but the precious cold gas itself. This is why Crystals 2 is a clear case of a galaxy actually being killed, rather than merely blowing off some excess hot material. The wind is reaching down into the cold, dense fuel and tearing it out. The one thing a galaxy cannot afford to lose. It takes a tremendously powerful outflow to do this, to lift and expel the heavy, cold molecular gas against the galaxy's gravity. And the fact that Crystal 02's wind is doing exactly that is what tells astronomers this galaxy is truly dying, not just venting. The murder weapon is not merely strong enough to blow away smoke, it is strong enough to tear out the heart. No one expects the difference between hot and cold gas to be the difference between a galaxy surviving and a galaxy dying, but that is exactly the distinction. No one predicts that expelling the easy hot gas would leave a galaxy alive, while expelling the heavy cold molecular fuel would kill it, and that Crystal 02's wind is powerful enough to do the latter. And absolutely no one anticipates how much the lethality of the death depends on this one detail, that ALMA caught the cold, dense fuel itself streaming away, the hard-to-move, impossible-to-replace material that a galaxy cannot lose and live. Pattern interrupt. Sit with the strangeness of that for a moment, because it inverts everything we expect about how a galaxy works. Expectation A galaxy forming stars furiously is a galaxy in the prime of life, vigorous, growing, thriving. Reality. Crystal 02's furious star formation is precisely what is killing it, because the very intensity of that starburst is driving the great wind that is expelling the galaxy's fuel. The galaxy is not thriving. It is burning so brightly and so fast that it is blowing itself apart from the inside, scattering the gas it needs to survive. Its brilliance is its death. The starburst is the suicide. No one expects the act of creating stars to be the very thing that kills a galaxy, but that is what Webb and ALMA caught Crystal 02 doing. No one predicts that a galaxy forming stars at twice the normal rate would, at that very same moment, be expelling its fuel at twice the rate it forms them, spending and wasting itself toward an early death. And absolutely no one anticipates how clearly the two telescopes together revealed it. Webb showing the furious burning life of the galaxy, ALMA showing the great cold plume of its fuel streaming away into the dark, the creation and the destruction caught in a single devastating image. So what is actually driving the wind? What is the force inside Crystal 02 that is taking its cold gas and hurling it out into the void? To understand the murder weapon, we have to look closely at what happens inside a galaxy that is forming stars too fast, because the killer, it turns out, is the stars themselves. Walk with me through the life and death of a massive star, because this is where the wind is born. When cold gas collapses to form stars, it forms stars of many different sizes, and among them are some true giants, stars dozens of times the mass of our Sun. These massive stars are spectacularly bright and spectacularly short-lived. They burn through their fuel in just a few million years, a cosmic eye blink, and as they burn they pour out fierce radiation and powerful winds of particles, pushing on the gas around them. And then, when they die, they do not fade quietly. They explode as supernovae among the most violent events in the universe, each one releasing in an instant more energy than the Sun will produce in its entire lifetime, blasting a shockwave outward through the surrounding gas. Tonight we're going to look more closely at the supernova, because it is the single most important driver of the galaxy-killing wind, and understanding just how violent one is makes the whole story of Crystal 02 land with its full weight. A supernova is the death of a massive star, and it is one of the most powerful events in the entire universe. When a star far more massive than our Sun reaches the end of its life, having fused its way through hydrogen and helium, and on through heavier elements, its core finally runs out of fuel and can no longer hold itself up against gravity. In a fraction of a second, the core collapses, falling inward catastrophically, and then rebounds in a titanic explosion that tears the star apart. For a few brief weeks, that single exploding star can shine as brightly as an entire galaxy of hundreds of billions of stars combined. The energy released in that instant is almost beyond comprehension, more than our Sun will radiate in its entire 10 billion year lifetime, all unleashed at once. And that explosion does not happen in empty space. It happens inside the galaxy, surrounded by gas, and it slams a shockwave outward through that gas at thousands of miles per second, sweeping it up, heating it, pushing it. A single supernova can carve out a great bubble in the surrounding gas, hundreds of light years across, a cavity of hot, expanding material ploughing into the colder gas around it. One supernova is a local catastrophe, reshaping its corner of the galaxy. Now multiply that. In a starburst like Crystal 02's, massive stars are forming in tremendous numbers, and because massive stars live such short lives, only a few million years, they begin to die in tremendous numbers too. Supernova after supernova exploding across the galaxy in quick succession, sometimes many in a single human lifetime's worth of time, though of course no human was there to count them. Each one drives its shockwave outward, and when many of them explode close together in the same region, over a short span, their bubbles merge, their shockwaves combine, their energy pools into a single vast outward push. Individual supernovae become a collective force, and that collective force is the galactic wind, a great hot outflow sweeping up the galaxy's gas and driving it outward, in the most extreme cases clean out of the galaxy entirely. This is the engine inside Crystal 02, not one supernova but a whole population of them exploding in concert, their combined fury driving the wind that is expelling the galaxy's cold gas. The collision triggered the starburst. The starburst made the massive stars. The massive stars dying together as supernovae drive the wind, and the wind carries the fuel away. Every step follows from the one before, an unbroken chain from the collision to the death of the galaxy. With the supernovae as the violent heart of it, the engines that turn a burst of creation into an act of self-destruction. No one expects the death of individual stars to add up into the death of an entire galaxy, but that is exactly what happens when enough of them explode together. No one predicts that supernovae, each one already among the most violent events in the universe, would combine their fury into a single wind powerful enough to strip a galaxy of its future. And absolutely no one anticipates how the largest catastrophe, the death of a galaxy, is built out of a multitude of smaller ones, supernova upon supernova, each a dying star, together a dying galaxy, the small deaths summing into the great one. Now consider what happens in a starburst, where stars are forming at a furious rate all at once. You do not get one massive star. You get many vast numbers of them, all of them blazing and blasting and then exploding one after another in a concentrated region over a short span of time. Each massive star pushes on the gas. Each supernova slams a shockwave into it, and when enough of them go off close together, in quick succession, their energy combines, their shockwaves merge, and together they drive a single enormous outflow, a great hot wind that sweeps outward through the galaxy, pushing everything before it. Astronomers call this a galactic wind, and in a powerful enough starburst, it becomes a galaxy-killing wind, strong enough to take the galaxy's cold gas and blow it clean out into intergalactic space. This is the murderer inside Crystal 2. The collision triggered the starburst. The starburst created a great crowd of massive stars. Those stars, with their radiation and their winds and above all their supernova explosions, drove a wind powerful enough to expel the galaxy's cold gas faster than the galaxy could form stars from it. The faster the galaxy forms stars, the more massive stars it makes, the more supernovae explode, the stronger the wind, the more gas is driven out. It is a runaway, a feedback loop of self-destruction. Star formation drives the wind, and the wind, by stripping away the gas, will eventually end star formation altogether. The galaxy is caught in its own machinery, and the machinery is tearing the fuel out of its own tank. This is what astronomers call stellar feedback, and it is one of the most important and most beautiful ideas in all of galaxy science, because it means a galaxy contains, built into itself, the seeds of its own death. The very process that makes a galaxy shine, the formation of stars, generates the force that can kill it. Creation and destruction are not opposites here. They are the same process seen at two moments. The starburst that lights the galaxy up is the same starburst that drives the wind that will put it out. There is something almost unbearably poetic in that. A galaxy that dies not despite its brilliance, but because of it, extinguished by the very fire that made it blaze. By the end of tonight, you are going to understand the reason astronomers were not entirely surprised to find a galaxy killing itself, and it goes back decades to a deep problem that emerged when theorists first tried to build galaxies inside computers. The problem revealed that galaxy-killing winds are not just something that happens. They are something that has to happen, or our entire picture of the universe falls apart. Here is the story. When cosmologists build simulations of the universe, recreating how galaxies form from the gas of the early cosmos under the pull of gravity, they ran early on into a serious failure. Their simulated galaxies formed far too many stars. Gas would fall into the galaxies, cool, and collapse into stars far too efficiently, producing galaxies vastly more massive and bright than any real galaxy we observe. The simulations made monsters, galaxies stuffed with far more stars than the real universe contains. Something was missing, some process that, in the real universe, prevents galaxies from turning all their gas into stars. Theorists called it the overcooling problem, the tendency of simulated gas to cool and form stars far too readily, and it was one of the central failures of early galaxy formation theory. The solution, it turned out, was feedback. The simulations were missing the violent self-regulation that real galaxies impose on themselves. When theorists added stellar feedback to their simulations, the energy of massive stars and supernovae pushing back on the gas, heating it and driving it out, the galaxies suddenly became realistic. The feedback prevented the gas from cooling and collapsing too fast, regulated the rate of star formation, expelled excess gas, and brought the simulated galaxies into agreement with the real ones. Feedback was not an optional extra. It was essential. Without it, the simulated universe was wrong, full of overgrown monster galaxies. With it, the simulated universe matched reality. The galaxy-killing wind, in other words, was theoretically required long before it was clearly observed. The universe simply could not look the way it does unless galaxies regularly drove powerful winds that expelled their gas and regulated their growth. Pattern interrupt. This is why Crystal 02 is a confirmation as much as a discovery. Theorists had concluded from the failure of their feedback-free simulations that galaxies must drive powerful winds, must expel their gas, must regulate and sometimes end their own star formation, or the universe would be full of galaxies far more massive than any we see. The galaxy-killing wind was a prediction, a theoretical necessity demanded by the very structure of the cosmos. And Crystal 02 is that necessity caught in the act, a direct observation of the self-regulation that theory had insisted must exist. The simulations needed feedback to make a realistic universe. Crystal 02 shows that feedback operating in its most dramatic form at the dawn of time. There is something deeply satisfying in this meeting of theory and observation. For decades, the requirement for galaxy-killing winds was an inference, a thing theorists knew must be true because their universe did not work without it. And now, with Webb and ALMA, we can watch one of those winds directly, expelling a galaxy's fuel, regulating its growth, bringing about its death, exactly as theory demanded. The prediction and the observation have met. The universe that the simulations could only build correctly with feedback is the same universe in which we now watch feedback tearing the fuel out of Crystal 02. Theory said it must happen. Crystal 02 shows it happening. No one expects the death of a galaxy to be something theory demands in advance, but the overcooling problem made galaxy-killing winds a theoretical necessity decades ago. No one predicts that the failure of feedback-free simulations, full of impossible monster galaxies, would be the thing that told us self-destruction must be real. And absolutely no one anticipates how perfectly Crystal 02 confirms the old prediction. The self-regulation that theory insisted must exist, caught at last in the act, expelling a galaxy's fuel exactly as the simulations demanded it must. No one expects the stars themselves to be the thing that kills their own galaxy. But that is the deep truth of stellar feedback. No one predicts that the brightest, most vigorous galaxies, the furious star formers, would be carrying inside their own brilliance the very wind that will expel their fuel and end them. And absolutely no one anticipates how intimate the connection is, how the act of creating stars and the act of destroying the galaxy are not two separate stories but one single story, the same fire that lights the room burning the house down around it. If the galaxy-killing wind of Crystal 02 feels remote, something happening only at the unreachable dawn of time, it is worth knowing that we can see the very same kind of wind, on a smaller scale, in galaxies near enough to study in beautiful detail, and one of them is a famous site in the nearby universe. About 12 million light-years from us, close by cosmic standards, there is a galaxy called Messier 82, often known as the Cigar Galaxy for its long, narrow shape. It is a starburst galaxy, forming stars at a furious rate, far faster than our own Milky Way, its star formation lit up by a close encounter with a larger neighbouring galaxy that stirred up its gas. And M82 is doing, right now in our cosmic neighbourhood, a gentler version of exactly what Crystal 02 is doing at the dawn of time. It is driving a great galactic wind. Out of the centre of M82, perpendicular to its disk, streams a vast outflow of hot gas, glowing, reaching tens of thousands of light-years into space, driven by the supernovae and stellar winds of its furious central starburst. It is one of the most studied and most photographed galactic winds in the universe, a textbook example of stellar feedback in action, close enough that we can map it in exquisite detail. When you look at images of M82, you can actually see the wind, great filaments and plumes of glowing gas erupting from the galaxy's heart, streaming out above and below the disk in a vivid display. It is one of the most dramatic sights in the nearby universe, and it shows the same machinery we have traced in Crystal 02, the starburst, the massive stars, the supernovae, the wind driving gas outward. M82 is not dying the way Crystal 02 is dying. Its wind is not expelling its fuel quite so catastrophically, but the process is unmistakably the same process, visible up close, in a galaxy we can study far more easily than any object at the cosmic dawn. This matters enormously for trusting the story of Crystal Q. We are not inferring the galaxy-killing wind from theory alone, or from a single distant ambiguous observation. We can see galactic winds directly in nearby galaxies like M82, watch them stream from starbursts, measure their speeds, trace their gas, confirm that the machinery works exactly as the physics predicts. The nearby examples ground the distant ones. When astronomers say that Crystal 02 is driving a galaxy-killing wind, they are describing a process they have watched in close detail in galaxies near enough to photograph beautifully. The dawn of time death is strange and remote, but the mechanism behind it is one we can see operating right now in our own cosmic backyard. There are others too. The nearby universe holds a number of starburst galaxies driving visible winds, each one a local laboratory for the process that kills galaxies like Crystal 02. By studying these nearby winds in detail, astronomers learn how the machinery works, how fast the gas moves, how much is lost, what drives it, and then they apply that understanding to the faint distant galaxies of the early universe, where the same machinery operated at far greater intensity. The near and the far illuminate each other. M82 helps us read Crystal 02, and Crystal 02 shows us what M82's machinery can do when it is turned all the way up. No one expects to be able to see a galaxy-killing wind up close, but in M82, 12 million light-years away, we can watch one stream from a starburst in vivid detail. No one predicts that the strange remote death of Crystal 02 would be driven by the very same machinery we can photograph in a famous nearby galaxy. And absolutely no one anticipates how the near and the far illuminate each other, the close-up winds of galaxies like M82 grounding and confirming the distant catastrophe of Crystal 02, the same process seen gently nearby and lethally at the dawn of time. There is, we should note, a second possible killer that astronomers watch for in cases like this, and it is worth mentioning for honesty. Many galaxies harbour a feeding black hole at their centre, and a feeding black hole can also drive a powerful wind, blasting gas out of the galaxy with its own ferocious energy. In some quenched galaxies, that black hole wind is thought to be the murderer rather than the stars, but in Crystal 02 the evidence points to the stars, to the starburst and its supernovae as the engine of the outflow, This is a death by stellar feedback, a galaxy killed not by the monster at its heart, but by the very stars it was busy creating. And that, in a way, makes it the more haunting story, because it means the galaxy needed no monster, no external enemy, nothing but its own act of creation to bring about its end. Tonight we're going to do something different for a few minutes and simply imagine being there, near Crystal 02, in the deep cosmic dawn, watching the death unfold, because we have described it in numbers and mechanisms, and it deserves, at least once, to be pictured as a place, a scene you could in principle behold. Picture yourself drifting in space, far enough from Crystal 02 to take it all in, about 1 billion years after the Big Bang. The galaxy fills your view, but it is not the calm pinwheel you might imagine from pictures of nearby galaxies. It is a galaxy in the chaos of a merger, two great clumps of stars and gas tangling together, distorted streamers of stars flung out by the gravitational violence of the collision. And it is blazing. Across its tangled body, stars are forming in tremendous numbers, vast nurseries lighting up, the whole galaxy shining with the fierce blue-white light of countless brilliant young stars, far brighter and bluer than any galaxy near us today. It would be a spectacle of creation, a galaxy on fire with new stars, dazzling, furious, alive. And then you would notice the wind. Streaming out from the blazing galaxy, perpendicular to its tangled body, would be the great outflow, a vast plume of gas erupting into space, reaching out thousands of light years into the dark. Near the galaxy it would glow, lit by the fierce starlight, filaments and sheets of hot gas driven outward by the combined fury of the starburst's massive stars and their supernovae. And mixed into that glowing hot wind, invisible to your eyes but real, would be the cold gas, the galaxy's precious fuel, being carried away with the rest, hurled out into the intergalactic dark at over 1 million miles an hour, never to return. You would be watching the galaxy breathe out its own future, a vast luminous exhalation streaming away into the void. If you could watch it sped up across the tens of millions of years of the death, you would see the wind blow and blow, the plume streaming ever outward, the galaxy's reservoir of cold gas steadily draining away. And slowly the blaze would begin to fade. With less and less cold gas remaining, fewer and fewer new stars would form. The brilliant blue light would dim as the brightest young stars aged and died with no new ones to replace them. The furious creation would wind down, the nurseries going dark one by one, the galaxy quieting, reddening, settling, and at last the wind itself would fade, the starburst that drove it finally exhausted, and what remained would be a quiet, reddening galaxy, its tangled body smoothing into the rounded shape of an elliptical, its blaze replaced by the gentle golden glow of its surviving older stars, the death complete, the afterlife beginning, pattern interrupt. There is something genuinely moving in holding that image, the blazing tangled galaxy breathing out its luminous future into the dark, slowly dimming, slowly reddening, slowly growing still. It is not a violent or frightening sight. It is, if anything, beautiful, a great slow exhalation of light, a galaxy spending itself brilliantly and then settling into quiet, like a bonfire burning fiercely and then sinking gradually into a bed of soft red embers. When you look at the faint smudge of Crystal 02 in a Webb image, this is what you're seeing, shrunk by 13 billion light years into a single mark. A whole galaxy blazing and breathing out its future and settling into rest. The grandest of slow fires burning down at the dawn of time. No one expects the death of a galaxy to be a thing of beauty, but the blazing tangled body of Crystal 02, breathing out its luminous wind into the dark and slowly settling into golden quiet, is exactly that. No one predicts that the faint smudge in our telescopes holds a sight so vivid, a galaxy on fire with creation, exhaling its own future into the void. And absolutely no one anticipates how much feeling there is in the picture once you let yourself hold it. A great slow bonfire of a galaxy burning fiercely and then sinking into soft red embers, beautiful and unafraid at the dawn of time. We mentioned that there is a second possible way to kill a galaxy, a different murderer, and it deserves a proper look because the question of which killer is responsible, the stars or the black hole, is one of the great debates in the study of how galaxies die. At the centre of nearly every large galaxy sits a supermassive black hole, millions or billions of times the mass of the Sun. Most of the time these black holes are quiet, sleeping, but when gas falls toward one and begins to feed it, the black hole roars to life. The gas spiralling inward heats to tremendous temperatures and blazes with radiation, and the region around the black hole can shine more brightly than all the stars of the galaxy combined. Astronomers call a feeding black hole like this an active galactic nucleus, and the energy it pours out can be staggering, enough to drive its own powerful wind, blasting gas outward through the galaxy, just as a starburst supernova do, but powered by the black hole instead of the stars. So there are two great engines that can drive a galaxy-killing wind. There is stellar feedback, the combined force of massive stars and their supernovae, which is what we have seen at work in Crystal 02. And there is black hole feedback, the wind driven by a feeding supermassive black hole at the galaxy's centre. Both can expel a galaxy's cold gas. Both can quench a galaxy, shutting down its star formation. And for years, astronomers have debated which one is the more important killer across the universe, which one is responsible for shutting down the most galaxies, and when and where. The current understanding still being worked out is that both matter but in different regimes. Black hole feedback is thought to be especially important for the most massive galaxies, where the central black hole is largest and most powerful, and where the deep gravity makes the gas hard to expel by stars alone. The black hole's tremendous energy may be needed to drive the gas out of these giants and keep it out, preventing it from cooling and falling back. Stellar feedback, the supernova-driven wind, is thought to be especially important in smaller galaxies and in intense starbursts, where the concentrated death of many massive stars can drive a wind powerful enough to clear the gas. The two killers divide the work, roughly, by the size of their victims. What makes Crystal 02 so valuable is that it appears to be a clear case of stellar feedback caught in the act, a galaxy being killed by its own stars rather than by its central black hole. The evidence points to the starburst and its supernovae as the engine of the outflow, not to a feeding black hole. This matters because it shows that stellar feedback alone, without any help from a monster at the centre, can drive a wind strong enough to kill a substantial galaxy. The stars need no accomplice. They can do it themselves. And in the early universe, where starbursts were common, and many galaxies had not yet grown their central black holes to full size, this stellar self-destruction may have been a particularly important way for galaxies to die. No one expects a galaxy to have two entirely different ways of killing itself, one driven by its stars and one by the black hole at its heart, but that is the strange truth of galactic death. No one predicts that the two killers would divide their victims by size, the black hole claiming the greatest giants, the stars claiming the starbursts and the smaller galaxies. And absolutely no one anticipates how clearly Crystal 02 shows the stellar killer acting alone, a galaxy needing no monster at its centre, nothing but its own act of creating stars to bring about its end. Tonight we're going to turn now to the question of time, because the most chilling number in the whole story of Crystal 02 is not how fast its gas is moving, but how little time it has left. When astronomers measured the rate at which Crystal 02 is losing its cold gas, and compared it to the amount of cold gas the galaxy still has, they could calculate something stark, a kind of cosmic life expectancy. At the rate it is currently expelling and consuming its fuel, with no fresh cold gas flowing in to replace what is lost, Crystal 2 will exhaust its entire reservoir of star-forming gas in a span of only tens of millions of years, tens of millions of years. By the measure of a human life, that is an unimaginable stretch of time. By the measure of the cosmos, it is nothing. The briefest flicker, less than 1,000th of the current age of the universe. In cosmic terms, Crystal 02 is not dying over the long, slow ages. It is dying almost instantly. We have caught it in the final moments of its life, and when those moments are over, it will fall silent. The star formation will end. The blue light of young stars will fade, and Crystal 02 will become exactly what so puzzled astronomers: a massive red and dead galaxy, finished and dark, far too early in the history of the universe. Before we get started on the bigger picture, there is a larger picture behind all of this, a grand cosmic cycle that the death of Crystal 02 fits into, and understanding it reveals that the expulsion of gas is not just an ending, but part of a vast circulation that runs through the whole universe. Astronomers sometimes call it the baryon cycle, baryon being the technical word for ordinary matter, the protons and neutrons that make up gas, and stars and planets and people. And the idea is that the ordinary matter of the universe is not locked in place. It flows. It circulates between galaxies and the space around them, in and out over billions of years, in a great slow breathing. Gas falls into a galaxy from the surrounding space, pulled in by gravity. The galaxy forms stars from that gas. The stars, through their winds and their supernova deaths, drive some of the gas back out again, into the space around the galaxy, and sometimes far beyond. And then, in time, some of that expelled gas may cool and fall back in again, to form new stars in another cycle. Gas in, stars formed, gas out, gas back in. A galaxy is not a sealed container. It is a node in a vast circulation, breathing matter in and out across cosmic time. The space around a galaxy into which this gas flows has a name. Astronomers call it the circumgalactic medium, a vast halo of thin gas surrounding every galaxy, far larger than the visible galaxy itself, a reservoir and a way station for the gas moving in and out. When Crystal 02 expels its cold gas, that gas does not simply vanish. It flows out into the circumgalactic medium, into the great halo around the galaxy, and beyond into the space between galaxies. Much of it, expelled at over 1 million miles an hour, is moving fast enough to leave the galaxy forever, lost to intergalactic space. But the expulsion is part of this larger circulation, the breathing out phase of the cosmic cycle, even if for Crystal 02 it is a breath the galaxy cannot afford. This is why the death of a galaxy by galactic wind is not simply a loss to the universe as a whole, even though it is a loss to the galaxy. The expelled gas enriches the space between galaxies. It carries with it heavy elements forged in the stars and scattered by the supernovae, seeding the intergalactic medium with carbon and oxygen and iron, the raw materials of future worlds. The wind that kills Crystal 2 also fertilizes the cosmos around it, spreading the products of its brief, brilliant life out into the wider universe, where they may one day become part of other galaxies, other stars, other worlds. The galaxy's death is a kind of scattering, a dispersal of its substance back into the great circulation from which all galaxies draw. Pattern interrupt. There is something almost consoling in this larger view. Crystal 02 is dying, yes, its own future expelled into the dark, but the matter it loses is not destroyed, only moved, returned to the vast cosmic cycle that flows through all galaxies. Its expelled gas joins the great reservoir between the galaxies, carrying the enriched ashes of its stars outward, where in some far future and some other place it may gather again, and cool again, and collapse again into new stars. The galaxy breathes out its life, and that breath becomes part of the breathing of the whole universe. Nothing is lost from the cosmos, it only changes hands. No one expects the death of a galaxy to be part of a vast cosmic breathing, gas flowing in and out of galaxies across billions of years, but that is the grand circulation the universe runs on. No one predicts that the very wind that kills Crystal 02 would also enrich the space around it, scattering the seeds of future worlds into the intergalactic dark. And absolutely no one anticipates how the largest loss, a galaxy's death, fits into a still larger pattern of renewal, the expelled matter rejoining the great cycle, carrying its enriched substance outward toward whatever the universe will build with it next. This is the resolution of the mystery we began with. The dead galaxies that astronomers kept finding in the early universe, the giants that died too soon, did not die slowly. They died like this. They formed their stars in a furious burst, often triggered by a collision, and that very burst drove a wind that expelled their fuel and shut them down in a cosmic instant. Crystal 02 shows us the mechanism in the act, the murder weapon mid-swing. The corpses make sense now, because we have finally seen the dying. And here is the part that gives tonight's story its full weight, the reason Crystal 2 matters far beyond itself. This is not a freak. It is not one unlucky galaxy meeting a strange end. The astronomers studying these early galaxies believed that this kind of violent self-destruction, this quenching by galactic wind, may be a common process, one that played out in a substantial fraction of the massive galaxies of the early universe. The same forces, the collisions, the starbursts, the supernova-driven winds were at work all across the young cosmos. Crystal 2 is not the exception. It may be closer to the rule, one clearly caught example of something that was happening over and over to galaxy after galaxy all across the early universe. The cosmic dawn, that time of vigorous youthful growth, was also a time of widespread death, a graveyard in the making, galaxies lighting up in brilliant bursts and then snuffing themselves out, everywhere, again and again. Pattern interrupt. Hold the scale of that for a moment, because it changes the whole picture of the early universe. We tend to imagine the cosmic dawn as a time of pure creation, of galaxies switching on, of light flooding into the darkness, a great cosmic spring. And it was that. But it was also, at the very same time, a season of dying, of giant galaxies burning themselves out in furious bursts, their fuel scattered to the intergalactic dark, their lights going out almost as fast as they came on, creation and death, all at once, all across the sky. The early universe was not just building galaxies, it was already burying them, and the same wind that we watch streaming from Crystal 02 tonight was blowing, in that era, from countless galaxies at once, a vast quiet exhalation of lost fuel, filling the spaces between the young galaxies, the breath of 1,000 dying giants. Let us pause, in the middle of all these numbers, and let the scale of what we are watching settle into something the body can hold, because the distances and times involved are so vast that they can stop meaning anything, and that is a loss worth resisting. When astronomers look at Crystal 02, they are looking at light that left it about 13 billion years ago, when the universe was only about 1 billion years old, a small fraction of its current age. Hold that against the age of the Earth, which is 4.5 billion years. The light from Crystal 02 began its journey toward us nearly 3 times longer ago than the Earth has even existed. When that light set out, there was no sun, no Earth, no solar system at all. The light crossed the growing void for billions of years before the Earth formed beneath its path, and then for billions more while life arose and oceans filled and the slow drama of evolution played out. And it arrived, finally in our telescopes, carrying the image of a galaxy that died, almost certainly, more than 12 billion years ago. We are not watching Crystal 02 die. We are watching the ancient light of a death that finished long before our world began. And consider the scale of the wind itself. That plume of cold gas streaming out of the galaxy extends some 7,000 light-years into space. 7,000 light-years. Our entire solar system, out to the most distant comets, is a fraction of a single light-year across. The distance from our sun to the nearest star is about 4 light-years, The plume of expelled gas is more than 1,000 times the distance to the nearest star, a tongue of frigid hydrogen reaching out across thousands of light-years of space, and it is being driven outward at over 1,000,000 miles an hour. The numbers are so large that they slide off the mind, a wind thousands of light-years long, moving faster than anything human beings have ever built, carrying away the mass of hundreds of suns worth of gas every year. Try to hold the timescale of the death too. Crystal 02 will exhaust its fuel in tens of millions of years, by human measure unimaginably long, by cosmic measure an instant. If you compress the entire history of the universe into a single year, with the Big Bang on the 1st of January and today on the last midnight of December, then the whole death of Crystal 02, from the starburst to the final silence, would play out in a matter of hours, less than a single day on that cosmic calendar. We have caught the galaxy in the final hours of its life, on the great clock of the cosmos, a brief bright flare and then quiet, over almost as soon as it began. Pattern interrupt. This is the thought I want to leave you holding, in the quiet. We are watching, in a single image, across 13 billion years, a galaxy of hundreds of millions of stars blow its own future out into a wind thousands of light-years long, and die, all in a cosmic instant, all of it finished and ancient before our world was even born. The gap between how small the galaxy appears, a faint smudge in our telescopes, and how enormous the drama actually is, a death on the scale of an entire star system playing out across thousands of light-years, is one of the quiet wonders of this science. Almost nothing reaches us, a faint smear of infrared and a whisper of radio. From that almost nothing, we reconstruct the death of a world of stars. No one expects to hold the death of a galaxy in a smudge of ancient light, but that is what Crystal 02 is, a whole world of stars dying across thousands of light-years, folded by distance into a faint mark in our instruments. No one predicts that a wind thousands of light-years long, moving at over 1,000,000 miles an hour, would arrive to us as the subtlest of signals, gentle enough to study from a quiet room at the end of a day. And absolutely no one anticipates how vast the real drama is behind the faint arriving light. An entire galaxy expelling its future into the dark, witnessed at last by creatures who came 13 billion years too late to do anything but understand. No one expects the time of cosmic creation to also be a time of widespread cosmic death, the two happening together, everywhere, at the dawn of the universe. But that is what these galaxies reveal. No one predicts that the great early starbursts, the most brilliant displays of cosmic creation, would so often be acts of self-destruction, galaxies killing themselves with their own light. And absolutely no one anticipates how common it may have been. How Crystals 2 is very likely just one clearly seen instance of a death that played out across a substantial fraction of the early universe's giants. A whole generation of galaxies that lived fast, burned bright and died young, leaving behind the red and dead corpses that first set the mystery in motion. By the end of tonight, you're going to understand another way astronomers study the death of galaxies, one that does not require catching them in the act at all, and it is worth knowing about because it confirms the story of Crystal 02 from a completely different direction. Astronomers call it galactic archaeology, and it means reading the history of a galaxy's death from the fossil record written in its surviving stars. Here is the idea. A galaxy's stars are like layers of sediment, a record of its history. Stars formed at different times have different compositions and different ages, and by carefully studying the stars in a galaxy today, especially a dead elliptical, astronomers can reconstruct when those stars formed, and therefore when the galaxy was actively making them, and when it stopped. The light of a galaxy's combined stellar population carries within it the signature of its star formation history, the record of when the galaxy was alive and burning, and when it fell silent. By reading that record, astronomers can determine, for a dead galaxy in the modern universe, roughly when in cosmic history it died, And when they do this for the massive dead ellipticals of the nearby universe, the answer is striking, and it matches everything we have learned tonight. The fossil record says that the most massive ellipticals formed the bulk of their stars very early, in a short, intense burst, and then quenched early, falling silent while the universe was still young. The stars in these giant dead galaxies are old, almost all of them formed in a brief early window, with little or no star formation afterward. The galaxy's own surviving stars testify that they lived fast and died young, exactly as the discovery of early dead galaxies suggested, and exactly as Crystal 02 shows in the act. Two completely different methods, catching galaxies dying in the early universe and reading the fossil record of long-dead galaxies nearby, tell the same story. The giants died early in furious bursts, just as we're watching Crystal 02 do. This convergence is what gives astronomers confidence, and it is worth understanding why. A single observation, however dramatic, could be a fluke or a misreading. But when two entirely independent approaches point to the same conclusion, the conclusion becomes hard to doubt. Catching Crystal JWST in the act of self-destruction at the dawn of time, and reading in the ancient stars of nearby dead ellipticals that they too died early and fast, are completely different kinds of evidence, gathered in completely different ways. That they agree, that both say the great galaxies lived fast and died young, makes the story far stronger than either could alone. The dying galaxy of the early universe and the fossil record of the dead galaxies nearby are two witnesses to the same crime, and their testimonies match. There is something poetic in galactic archaeology, in reading the death of a galaxy from the very stars that survived it. The dead ellipticals carry their own history within them, written in the ages and compositions of their stars, a record of their brief bright youth and their early death, preserved for billions of years in the light of their surviving population. We do not always need to catch a galaxy dying to know how it died. Sometimes we can read it, long afterward, in the fossil light of what remains, the old stars themselves remembering and quietly telling us the story of the galaxy's brief life and its early, furious end. No one expects to read the death of a galaxy from the fossil record of its surviving stars, but galactic archaeology does exactly that, reconstructing when a galaxy died from the ages of the stars it left behind. No one predicts that this completely independent method would confirm in nearby dead galaxies the very same story that Crystal 02 shows in the act, the giants dying early and fast, and absolutely no one anticipates how two such different witnesses, a galaxy caught dying at the dawn of time and the fossil stars of the long dead nearby, would testify so perfectly to the same truth, lending the whole story a confidence that neither could give alone. By the end of tonight, you're going to understand where Crystal 02 fits into the grand sweep of cosmic history. We need to step all the way back and look at the entire star-forming life of the universe, because the universe as a whole has a birth rate, a rhythm of star formation that rose and fell across billions of years, and the deaths of galaxies like Crystal 02 are part of why it fell. Astronomers have managed to measure something remarkable, the total rate at which the entire universe was forming stars across all of cosmic time. By surveying enormous numbers of galaxies at many different distances, and therefore at many different ages of the universe, they have reconstructed the cosmic star formation history, the universe's heartbeat as a whole, from the cosmic dawn to the present day. And that history has a clear shape. In the early universe, star formation rose rapidly, more and more galaxies lighting up, the cosmic birth rate climbing higher and higher. It reached a great peak when the universe was a few billion years old, a time astronomers vividly call cosmic noon, when the universe was forming stars faster than at any other moment in its history, a great blaze of cosmic creation. And then, after cosmic noon, the rate began to decline. Star formation across the universe has been falling, gradually but steadily, ever since. Today, the universe forms stars only a fraction, as fast as it did at cosmic noon. The great creative blaze is past its peak, and the cosmos, as a whole, is slowly winding down. Crystal 02 lived before cosmic noon, in the Great Rising phase, but its death is part of the story of why the decline eventually came. The universe's star formation peaked and then fell for a combination of reasons, and one of the most important is exactly what we have been watching tonight. Galaxies ran out of accessible cold gas, and they ran out of it in part because they expelled it through the very galactic winds we have traced in Crystal 02. Across cosmic time, galaxy after galaxy formed its stars, drove its winds, lost its fuel and quenched, falling silent one by one. The expulsion of gas multiplied across countless galaxies over billions of years helped to drain the universe of its readily available fuel, and so helped to bring the great cosmic blaze down from its peak. Crystal 02 is one small part of that vast process, one galaxy's contribution to the slow winding down of the universe's capacity to make new stars. There is a sweep to this that is worth pausing on. The universe is not forming stars forever at a constant rate. It had a youth of rising creation, a peak of maximum blaze at cosmic noon, and now a long, slow decline that will continue into the deep future, as more and more galaxies exhaust or expel their fuel and fall quiet, as the cold gas of the cosmos is gradually used up and scattered. Far in the future, star formation across the universe will dwindle to almost nothing, the last stars forming from the last available gas, and then a long darkness as the existing stars slowly burn out. The death of Crystal 02 is a single early note in that vast slow movement, one galaxy quenching in a universe that, as a whole, is itself slowly, gracefully, quenching across the great span of cosmic time. No one expects the universe as a whole to have a birth rate that rose, peaked, and is now declining, but that is the shape of cosmic history, a great blaze at cosmic noon, and a long, slow fading after. No one predicts that the deaths of individual galaxies, expelling their fuel through galactic winds, would add up across billions of years to help bring the whole universe's star formation down from its peak. And absolutely no one anticipates how Crystal 02's single death fits into that grandest of patterns, one early galaxy quenching within a universe that is itself, across the vast reach of cosmic time, slowly and beautifully winding down. By the end of tonight, you are going to carry one more thought with you, gently, and it concerns us. Because the same kinds of forces, on a smaller and slower scale, operate in our own galaxy too. Galactic winds driven by star formation blow from the Milky Way even now, lifting gas above and below its disk. We are not dying as Crystal 02 is dying, not even close. Our star formation is gentle and steady, not a furious self-destructive burst. But the machinery is the same machinery. Every galaxy that forms stars carries within it to some degree the seeds of the same end. Crystal 02 simply shows us that machinery turned all the way up, running to completion in the brilliant brief life and abrupt death of one galaxy at the dawn of time. Tonight, we're going to bring this home, all the way home to our own galaxy. Because the natural question, once you have watched a galaxy kill itself, is whether the same thing could happen to us. And the answer is reassuring, but more interesting than a simple no. The Milky Way, our home galaxy, is a spiral, a great rotating disk of several 100 billion stars, and it is still very much alive, still forming new stars, but it forms them gently. Our galaxy turns roughly 1 or 2 suns worth of gas into new stars each year, a slow and steady rate, nothing remotely like the furious starburst of Crystal 02, which was forming stars dozens of times faster. The Milky Way is not in a frenzy. It is in a calm, sustainable middle age, forming stars at a pace its fuel supply can support, replenished by gas slowly falling in from the space around it. We are in no danger of the violent self-quenching that is killing Crystal 02. Our heartbeat is steady, not feverish, and yet the same machinery is present in our galaxy too, running quietly. The Milky Way does have galactic winds. Above and below the flat disk of our galaxy, astronomers have found gas being lifted out driven by the winds and supernovae of our own star formation, the same kind of process as in Crystal 02, only far gentler. There are even enormous structures, great bubbles of hot gas, extending tens of thousands of light-years above and below the centre of our galaxy, blown outward by energetic activity in the Milky Way's past, possibly by our own central black hole or by bursts of star formation long ago. The machinery of galactic winds is not foreign to us. It operates in our galaxy right now, mild and survivable, lifting some gas, losing some fuel, but nowhere near the lethal intensity of a true starburst. So we are safe, for now and for a very long time to come. The Milky Way will go on forming stars for billions of years yet, its gentle heartbeat continuing, its fuel slowly replenished. But our galaxy will not live forever in its current bright spiral form, and here is where Crystal 02 becomes, in a way, a glimpse of a distant future. In about 4 billion years, the Milky Way is expected to collide with the great neighbouring Andromeda galaxy, the two spirals merging over hundreds of millions of years into a single larger galaxy. And that merger, like the one that triggered Crystal 02's starburst, may crush our combined gas and ignite a burst of star formation, brighter than anything our galaxy does now. Whether that future burst would be furious enough to drive a galaxy-killing wind, no one can say for certain. But it is possible that our galaxy's eventual transformation into a red and dead elliptical, the fate that very likely awaits it in the deep future, will involve, in some gentler form, the same kind of process we are watching tear through Crystal 02 tonight. So Crystal 02 is not only a distant stranger, it is, in a sense, a distant mirror, showing us in extreme and accelerated form a version of what our own galaxy may one day, far more gently and far in the future, pass through. Not soon, not for billions of years, and not, we expect, with the same violence. But the machinery is the same machinery, and the long arc of a galaxy's life, from bright star-forming youth to quiet red afterlife, is an arc our own galaxy is travelling to, slowly, in its own time. Crystal 02 simply shows us the far end of that arc, lit up brilliantly and reached quickly, the destination toward which all star-forming galaxies, including ours, are gradually moving. No one expects our own galaxy to share the machinery of a dying galaxy at the dawn of time, but the same winds, gentler, blow from the Milky Way even now. No one predicts that our distant future, the merger with Andromeda, and the eventual fading into a red and dead elliptical, would echo, in slow and gentle form, the violent death we watch in Crystal 02. And absolutely no one anticipates how Crystal 02 turns from a distant stranger into a distant mirror, showing us, in brilliant and accelerated form, the far destination of the long quiet road our own galaxy is travelling to. So let us gather the whole journey now, gently, the way you would draw the threads of a long story together before sleep. We began with a mystery, the galaxies that died too soon, the massive red and dead giants that astronomers kept finding in the early universe, finished and dark long before the cosmos had grown up. We saw that to kill a galaxy, something must either heat its cold gas or strip it away entirely, ending the star formation that is a galaxy's heartbeat, and that the question of what does this and how it acts so fast has been one of the great unsolved puzzles in the study of galaxies. And then we watched James Webb and the great radio array of ALMA turn together toward Crystal 02, a galaxy 1 billion years after the Big Bang, and catch it not dead but dying. We saw the furious starburst, twice the normal rate triggered by a collision. We saw, in ALMA's eyes, the great plume of cold gas streaming 7,000 light-years out into the void, the galaxy's own fuel being expelled at over 1 million miles an hour, at twice the rate the galaxy was forming stars. And we understood, finally, the murderer, the stars themselves, the massive ones, their radiation and winds, and above all their supernova explosions combining into a great galactic wind, a galaxy-killing wind, powerful enough to blow the galaxy's lifeblood out into intergalactic space and silence it within tens of millions of years. We saw that creation and destruction here are the same act, that the very brilliance of the starburst is what drives the wind that ends it, a galaxy dying not despite its fire but because of it. And we saw that Crystal 02 is no freak, that this kind of self-destruction may have played out across a substantial fraction of the early universe's giant galaxies, that the cosmic dawn was a season of death as much as a season of creation, countless galaxies burning bright and snuffing themselves out all across the young sky. It is worth knowing that the story of Crystal 02 is not finished, that this single dying galaxy is the beginning of a larger investigation, and that the coming years will reveal whether it is truly the common process astronomers suspect, or a more unusual case. Tonight, we're going to look at how the science moves forward from here. Crystal 02 is one galaxy, one clearly caught example, and a single example, however dramatic, is not the whole story. What astronomers need now is many more, a whole population of early galaxies studied in the same way, with Webb and ALMA together mapping both their burning star formation and their cold expelled gas, to see how often this violent self-quenching is happening. The ALMA Crystal Survey, of which Crystal 02 is a part, is precisely this kind of effort, a systematic study of early galaxies designed to build up a statistical picture, not just of one death, but of many, to learn how common the galaxy-killing wind really is across the early universe. Each new galaxy studied adds to the picture, and over the coming years that picture will sharpen from a single vivid case into a real understanding of how widespread this process was. There are specific questions the ongoing work will answer. How many early galaxies are driving these powerful outflows? How much of the gas they expel is truly lost forever, and how much eventually falls back? Exactly how the rate of quenching by stellar feedback compares to quenching by the central black hole across different galaxy sizes and different cosmic eras. Whether the substantial fraction of self-destroying galaxies that astronomers suspect holds up as more are studied, or whether Crystal 02 turns out to be somewhat unusual after all. These are real open questions, and the honest answer to many of them right now is that we do not yet fully know, and that more observations are needed to settle them. The instruments are ready for the task. Webb continues its work, gathering the infrared light of more and more early galaxies. ALMA continues to listen for their cold gas. And other facilities are joining the effort, new and upgraded telescopes that will deepen and widen the survey of the early universe. The combination of Webb's vision of star formation and ALMA's vision of cold gas is a powerful new way of studying galaxies, and it has only just begun to be applied at scale. Crystal 02 is one of the first dramatic results of this combination, and many more are surely coming, each one adding to our understanding of how galaxies lived and died at the dawn of time. What is genuinely exciting is how new all of this is. The combination of Webb and ALMA to catch galaxies in the act of self-destruction is a development of just the last few years, and the result we've explored tonight comes from work published in this very era, fresh from the frontier of the science. We are not looking at settled, ancient knowledge. We are watching a piece of the universe's history being understood in real time, the mystery of the early dead galaxies being solved as we speak, one caught death at a time. The picture will grow richer, the numbers firmer, the understanding deeper, in the years just ahead. No one expects a single dying galaxy to open a whole new program of discovery, but that is what Crystal 02 represents, one clear case at the start of a systematic search. No one predicts exactly how common the galaxy-killing wind will turn out to be, and only the gathering of many more examples will tell. And absolutely no one anticipates how alive this science is right now. The mystery of the early dead galaxies being solved in our own moment, with the best instruments ever built, one caught death at a time, the picture sharpening even as we watch. No one expects the act of making stars to be the act that kills a galaxy, but that is the quiet truth Crystal 02 reveals. No one predicts that the brightest galaxies would carry their own deaths inside their own light, and absolutely no one anticipates how gentle the final picture feels once the word death stops sounding like a catastrophe and starts sounding like what it is, a natural part of the long turning of the cosmos, galaxies living and dying as everything does, in their own vast and unhurried way. Because there is a strange comfort in this, and it is the thought I want to leave you with. Crystal 02 is not suffering. It does not know it is dying. It is simply a galaxy doing what galaxies do, forming stars and being shaped, as all things are, by the consequences of its own nature. Its death is not a tragedy in the way a human death is a tragedy. It is a transformation, a galaxy passing from one phase of its long existence into another, from the brilliant burning life of a star former into the quiet red afterlife of an elliptical, where its old stars will glow on gently for tens of billions of years to come. Nothing is truly lost. The light only changes. The galaxy does not end. It only grows quiet, and so will the night. Far away and long ago, a galaxy burned brilliantly at the dawn of time, and in its brilliance it breathed out its own fuel into the dark and began slowly to grow quiet. Its light has been travelling toward us for 13 billion years, carrying the story of that brief bright life and that gentle death, and it arrived at last in the mirrors of our telescopes, and we understood it, and now we can rest with it. The dying galaxy asks nothing of us. It only shines far off in the deep past, doing what it has always done. The starburst is blazing 13 billion years ago. The cold gas is streaming out into the dark. The galaxy is growing quiet, passing gently from its bright life into its long red afterlife, exactly as the cosmos intends. And you are here, at the other end of all that ancient light, warm and still and safe. At the end of a long day, watching a galaxy die the way you might watch a fire burn down to embers, without fear, without grief, simply present for the slow and beautiful turning of it. Let the galaxy grow quiet. Let the night grow quiet. Let yourself grow quiet. Sleep well tonight. Good night.